Hello everyone and welcome to my class. Today we will be learning about functions again. So let me share my screen first. Okay. Alright, so if you can see my screen, say yes in the chat. If you can't, say no. So can you see my screen or not? Yes, very good. Okay. Let's start. So this is our second class on functions. And let's start by introducing the schedule today. Today we're going to do a review first of last class, and then we're going to go over properties of functions or theorems, and we're going to do some practice problems. All right. So our review. Let's go over the definition of a function. Okay. So what is a function? Does anybody know what a function is? All right. Yes, Isabella. I'm assuming you're going to answer the question. Yeah, input and then output. Yes, that is very basic definition of it. Hold on, let me make it so you can unmute. Okay. So, Isabella, you're raising your hand, so I assume you have an answer to my question, or do you have a problem? You can unmute now. Yes. Can I? Great. You can go get a notebook. Yeah, you can go get whatever notebook you need. But this is very basic stuff, so. Okay. So now let's go over the definition of function. So what is a function? A function is a correspondence. Hold on. What? Yeah. Is correspondence f from a set D to a set E. Such that for each x, so such that each x that is in the set D there is a unique y that is in set E. All right, so that is the definition of a function. A correspondence f from a set D to a set E such that each x in D there is a such that for each x. I need to. All right. No, not there. I'm failing at grammar. I know. Such that for each x in D there is a unique y in E. So what does this look like? Let's say we have this circle here is D. Let's call this D. I need a better circle. Okay. And then this set here, the circle here is E. And we're going to have X, X1 here, and we're going to have a Y here. All right. And this X1 is going to correspond to this Y, and that correspondence is called F, which is our function. Now, it's important to note here that f of x can assign more than one x to the same y, but not vice versa. So what does this look like? So we can have another correspondence here. Let's make that orange. We can have an x2, then that can also correspond to y. That's okay. That's part of the definition of a function, right? But what you can't do is you can't have You can't have x1 corresponding to y1 and y2, right? That's not okay. So fx can assign more than one x to the same y, but f of x cannot assign one x to more than one y. All right, so make sure to note that. So now let's review what is domain and range. Okay, so basically D is the domain of F. All right, D is the domain of F. And then an E is not the range, right? It is the target space. So how do we find the range? To define the range, you need to let R equal for any y in the set E, and y equals fx for some x in D, then R is the range of F. Now, this might sound very confusing to you, so let me give you what the simple definition of range is in D. Okay, so you see here, we have a graph here. Let's say we have, okay, I need to make a better graph. This is way too small. All right, let's make a graph here. Nope, still failing. Oh, I see. Apparently it doesn't want to, how is this even possible? Okay, finally. So we have our mediocre graph right here, very mediocre. So, and we have, let's say we have this function here. And this is from A to B and C, and this is D here. Okay? So, if you were to find the domain of this, let's call this G of X, all right? If you find the domain of G here, then you would get A to B, an interval of A to B inclusive. And if you find the range of G here, then you would get C to D inclusive. Then from this you can infer that the domain is all the X values and the range is all the Y values. So that is the domain and the range. All right, so yes, that is a class. Well, this is about functions, if you couldn't tell. Okay, so is everybody understanding what I'm talking about? Is this understandable? Not too hard? Okay. So I'll move on to finding the natural domain of function. What is a Google Classroom? What is a Google Classroom? I know. What is a Google? I don't even know what a Google Classroom is. But I always use Zoom classes, and I'm too lazy to create whatever classroom that is. So yeah, great. Okay, so let's review some let's review some things here. So to find the natural domain of F. So who knows how to find the natural domain of this? Okay, naturally, if you were to get into, if you were to, all right, so if you had a function fx equals x, then that is called a all real function. So a function is naturally the domain of this would be all real numbers, which is negative infinity to infinity. All right. So basically, the domain of this function would be negative infinity to infinity, except you exclude the cases where this fx is undefined. So when is it undefined? Well, there are two cases. There are two common cases where it can be undefined. Two common cases, which is when you square root a negative number. That's just an imaginary, right? Or when you divide by 0. When you divide by 0, that's going to be undefined. Okay? So these two cases, with these two cases in mind, how would you find the domain of f? You're going to exclude these the cases where it is undefined. All right. Okay. So x must be positive, right? And all real numbers that are not 2 or negative 3. Okay. So yes, very good, Stephen. So the domain of f would equal x is a real number, obviously, and x must be greater than or equal to 0, and x minus 2, x plus 3 cannot equal 0. Now, let's take this here, all right? Since if you're not equal to 0, you can kind of solve it just like it's equal to 0. So how would you solve this quadratic equation, right? You'd get like x equals to 2 and x equals to negative 3. But since it's not equal, then it cannot equal 2 and cannot equal to negative 3. So we get this set here. All right. Okay, so after we get these, so you can kind of see that the domain, you've already figured it out, right? So how would we solve this? Since x has to be greater than or equal to 0, then we can kind of just exclude negative 3. It's negative, right? It's not even included anyways. So you get 0 to 2, union 2 to infinity. All right, so does everybody agree with this solution? Are there any problems? Any problems? Or any questions? Are there any questions about how you solve this? Any questions? Okay. Is that a yes for a question? Oh, okay, no questions. Great. So now let's continue. Let's find another one. Okay, and this you need to use the sign chart. All right. I know. Yes. Okay, so how would you find the natural domain of f? Now we're running kind of out of time. We're running late, so let me just solve this for you. So the domain of f would equal to x is in all real numbers, and what does this thing equal right here, right? What does it equal? Basically, if you take the square root of everything, then everything inside here has to be greater than or equal to 0, right? That means that 2 minus x and 2 plus x over 3 plus x and 5 minus x has to be greater than or equal to 0. All right? And now that we have this, we can use our sign chart to solve it, right? So let's list out our intervals, and Some new students, if you don't understand the sign chart method, it's you probably didn't go to my earlier classes, and we talked about the sign charts in my previous classes. So it's all on my YouTube channel if you want to check it out. Though I'm probably too lazy to. Yeah, I probably was too. Did I even upload it? I wonder. No. I think the inequality ones are still there. Okay, so we do this. Okay, so we're gonna exclude the intervals where well, we're gonna exclude the zeros here. So the intervals where this fx does not, well, this thing does not equal 0. All right, so I'm gonna have 2 here. Okay, union, oh wait, never mind, -3 first. Okay, union -3 to -2. All right, union, oh no, not union yet. Oh, I'm messing up, aren't I? Okay, -3 to -2. You can just list out this negative. Okay, yeah. And then we get 2 to 5, and then 5 to infinity. Okay, so extend this. Okay, so now let's list all this stuff here. Okay. So now we just kind of need to solve the inequality, right? You just need to solve the inequality, so we get negative, negative, plus, 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 and then plus, 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 minus, minus, and then negative, plus, 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 negative. Okay. We get plus here, positive here, negative, positive, negative, positive. Okay, so our 3 intervals, the domain of f would equal -infinity to -3 union. Actually, yeah,
I think you got something wrong with the -infinity to -3.
the -infinity to -3.
Yeah, I think you got the first one wrong. It should be positive instead of negative. Like 2 minus x,
2
it
minus
should
x.
be it should be positive. So 2 minus x and -infinity to -3, it should be positive instead of
Hold
negative.
on, let me check that. So 2 minus x is greater than 0. Then negative x is greater than -2. Then x is less than 2. Okay. So when x is less than 2, oh, yes, I got this wrong. Hold on. Okay. Thank you for reminding me, Edward. Okay, so then this would be plus, right? Yep. Plus, plus, negative, negative. Okay, yeah, I mixed it up. Negative, negative, plus, plus, plus. Well, it's, I think, yeah, it's still the same result. Yes, still the same result, but yeah. Okay, made a small mistake here. So our answer would be -2 to 2. Oh, I don't have enough space. Let's write it in under this. Okay, so it'd be -infinity to -3 union 2 to 2 union 5 to infinity. All right, so thank you for catching my mistake there. So this would be the domain. All right. So are there any questions on that? Any questions? No questions? All right. So let's actually not do this one. You've had enough, probably. So that's just graphing. If you learn about like the what is this? Top I think this is the bottom half. Bottom half of the circle. Yeah. If you learn about the bottom half of the circle equation of that, you should know this. If you don't, just you can go back and watch my previous videos. but we don't need to do that. That's insignificant. All right, so now let's learn about the properties of functions, and that's the main idea that we want to touch on today. Okay, so hold on. All right, so let's begin. First of all, I want to introduce this graph of a function here. Okay, let's make it over here. All right, so our graph here is gonna be like that, kind of. No. Okay, it's gonna be like that, kind of. Yeah. No, this is okay. Maybe I should draw the points first. Yeah, that kind of looks better. Okay, so this is 2. This is also 2. This is 4. This is 0. And this is -2. Okay, so yeah, no. No. I'm gonna change this. Okay, so this is -2. Yeah, okay, that looks a bit better. So this is our graph we're gonna use to do these properties. Or this is our graph we're gonna use. So now, so you can see that, okay, so actually, I'm gonna give you a question. All right, this is a question. So let's say this is called y equals fx. This is f of x. Okay, so this is the graph of that. So what would happen? What would f look like if we added 1 to it? What would the graph of y equals fx plus 1 look like? What would that look like? Okay, how are we going to do this? So, all right, it moves the whole graph of fx up the y-axis by 1, right? Okay, very good. So let's make a chart. Okay, make a chart. We're gonna make a chart here. And then we're gonna have f of x plus 1. All right, so this chart sucks too. Gotta be kidding me. Okay. Oh, we're wasting much time here. Okay, so when x equals 0, f also equals 0. Okay. When x equals 1, f of x equals 2, and 2, 0, 3, -2, and 4 is going to be 1. 0, actually, yeah. Okay, so if we were to add that, if we were to add 1 to f of x, then just add 1 to each of these values. Okay, and if you plot those points, you can see that they're one above the previous ones. Okay, like this. And you can see that it shifted up by 1. So our theorem here, okay, let me create some space. So our theorem here about f of x plus c, what would that be? So that would be like the graph of y equals f of x plus c, and what can be obtained. All right, can be obtained by shifting the graph. How are we going to shift this? Are we going to shift this horizontally, diagonally, or vertically? We're going to shift this vertically, all right? By shifting the graph vertically. All right? We're going to shift it vertically by C, the absolute value of C units. All right? Now, if C is greater than 0, then we shift up. And if C is less than 0, then shift down, right? All right, so that is our theorem, okay? So are there any questions on how we obtain this theorem? Any questions? If there are no questions, then I'll move on. All right, since there are no questions, oh, wait. We need to touch up on a very important subject. So the domain, when you're graphing a function, is very important, all right? The domain is very, very important, but this does not change the domain. So since it shifts up or vertically, does not change domain. Now, when do we change domain? All right, and we'll see that in our in a couple theorems after. And when you change domain, it means you're changing the x directly, like multiplying. Let's say you have y equals f2x. That is changing the domain. But since we're adding something onto it, we're not. All right. So let's look at this. What do we get when y equals cf cfx, right? Cfx. Okay. So what are we going to get? Oh, you don't get this. Okay. So which part do you don't get? Which part? If you didn't get the review problems, that's fine. You can always review the lecture of last time again. But if you don't get this, then I'll going to help. I'll help you. Okay. Which part do you don't get? Do you don't get do you not get the theorem 1? Oh, you're new, so you don't really get it. Which part do you don't get? Do you not get everything, or oh, you shouldn't not get everything. Okay. The theorem. This one. Okay. This theorem. All right. Oh, I need to okay. Let me talk about this theorem, and then I'll use the same example, right? I'm using the same example, and you should get it after I see. Hold on, I didn't show the example long enough. All right, so let's look at this one first. If you still don't get this one, I'll go back. Okay, so let's say I wanted to sketch y equals 2f of x. All right, 2f of x. And we're using the same example, right? We're using the same example. All right. Which is like this. Okay? The same example. Okay, so if we use the same example, okay, this line is just, no, that's not going to happen today. Finally. Okay, so if you use this example, right? The same example, and these are points you get. So I have this chart here. Okay. And we're gonna have 2f of x here and just f of x here. All right, so when x is 0 here, then f of x equals 0. See this point here? All right, because f of x basically equals y, right? Y equals f of x. So the x, so this point would be x and f of x. All right, so when the x value is 0, then the f of x value would equal 0, right? Hence this point. And then when x equals 1, then the y value would equal 2, right? And then so forth. Okay, I'm just going to fill it in for you. 3, -2, and 4, 0. Okay, now if you were to multiply these values, this value, by 2 because of 2f of x, then you get 0, 4, 0, -4, and 0, right? And you can see here that you kind of you stretched it vertically, right? You stretched it vertically. This is our result here. This is our result. So our theorem is this. The graph of CF of x, okay, of y equals CF of x can be obtained. No, this B sucks. Okay, that's a good B. Okay, excuse my handwriting. The graph of y equals CF of x can be obtained by what do you do here? You stretch the graph vertically, right? By stretching or compressing, right? By stretching or compressing, right? You can compress too. So how would you compress? Does anybody know how would you compress the graph of fx? So if you were to compress it, okay, yeah. Divide by c. Not really. Well, you could, but it's gonna be, let's say, since it'd be 1 over c. If c is an integer, then it would be 1 over c. Okay, if c is an integer, it would be a fraction, right? A fraction, then it's compressing it, right? If you had 1/2 f of x, then it would compress. It'd be this. It'll be like this, flatter. Okay, that is what it would be, right? So but the graph of y equals cf of x can be obtained by stretching or compressing, right? Or compressing in a ratio of 1 to c, the absolute value of c, vertically. All right. So if c is greater than 1, stretch. Okay. And then if c is less than 1, well, it can't be negative though. Can't be negative. 0 to is in the interval 0 to 1, not inclusive, then compress. So that is our theorem. Okay, and it does not change domain either, because it does not directly change this x here. So it does not change it does not change the domain. All right. So let's move on to our third theorem, which will change domain. Okay, it changes the domain because it directly affects this x right here, right? So hold on. So Isabella, do you understand now? Oh, what happens when c is less than? Oh, first theorem again. Okay. Hold on. Yeah, this is the first theorem. It was obtained the first with the same example, right? So if you find any graph and do these and just add a one or multiply it, you get like the same result, right? Okay, so back to your question. Okay, yeah, screenshot, great. What happens when c is less than 0? All right, so when c is less than 0, that's a very good question, all right? It reflects over the x-axis vertically, all right? Let's say if you multiply by -2, then this would be negative, this would be plus, right? So you reflect like this, all right? So that is what happens when you get negative c of x, all right? Okay, so now if you had f of x minus c, what does that do? Now that changes the domain. Okay, so when you see this, it directly affects this x, all right? It's in this parentheses, all right? Then you must need to to change the domain, right? So let's use our same example. It'll be over here for reference. And the domain of this, the original domain of this function, f of x, is 0 to 4, right? Now, what would happen if we subtracted c? Okay, let's sketch. No, let's not sketch that. That'll take too long. Let's check y equals f of x minus 1. All right, let's see that. How would that change? All right. So if you were to find the domain of f of x minus 1, how would you do that? All right. So since the domain of f equals 0 to 4, which equals 0 like this, if you want to put it in a set, then the domain of f of x minus 1, that would equal what? This, right? Since the domain of f equals 0 to 4, and we can put it in this notation here, okay, then we can also put the domain of f of x minus 1 in here, right? We can also do that, okay? And if you solve this, you can find that it's going to be 1 to 5. So our new domain is 1 to 5, okay? Inclusive. So it changes the domain. All right, and you can see from this that our new thing, our new function is going to be shifted to the right by 1 unit, right? Okay. Are there any questions on this? Any questions on how I did this example? Any questions? If there are no questions, I'll write the theorem. Okay. So there are no questions. Okay. So our theorem here would be the graph of y equals f of x minus c can be obtained by shifting horizontally. Last time we did it was vertically, right? But this time, since it directly affects x, then it would change the domain, which means the x value changed, right? So it'd be shifting horizontally. By shifting horizontally by absolute value of c units. All right. If c is greater than 0, what do we do? If c is greater than 0, what do? We shift right. Okay. Now, what happens when c is less than 0? Okay. If c is less than 0, then shift left. Okay, so are there any questions? Any questions? If there are no questions, then I'll move on to another theorem. Okay, so no questions? All right. And this does change the domain, all right? This changes the domain. Okay, that's very important. Changes the domain. And the second one on this is a fourth theorem. Yeah, fourth theorem. Now this is the fourth theorem, and this also changes the domain, okay? Because it directly affects this x over here. And let's see what happens when we're going to multiply this x by c. All right, so let's use our same example here. Here it is for reference. And so our theorem 4 right here. Okay, what is it? And after this, we're going to look at some absolute value. What does absolute value does? What does absolute value do to these functions? All right, so after this, we'll learn about absolute value. Okay, so let's look at our example. What if we had an example? Let's try to find n. Okay, let me do the domain here first. Okay, so let's look at the graph. No, let's look at the domain of y equals f of 2x. All right. So what does that do? Okay, are there any thoughts on what does 2x do to the function? What would it do? Okay, we know it's gonna be, since it affects the domain, it's gonna do something horizontally. So what is it going to do horizontally? Shift to right. I'm afraid that's incorrect because we just shifted to the right by adding or subtracting. But that's a good idea. Are there any other ideas? Any other ideas? Squeeze it. Yes, we're gonna compress it. We're gonna compress it horizontally, right? Compress it horizontally. So let's look at the domain of this. All right. So the domain of f to x, what is that gonna be? It's gonna be x is in all real numbers. Okay. And we're going to get this inequality right here, right? Okay. And that's going to turn out to be our interval 0 to 2, right? See, it's compressed. It's compressed by a factor of 2, right? It's compressed. And see, our new graph here, if we did f of 2x, it'd be compressed. Because, okay, let's do our chart here. So all right. So this would be fx. And this would be f of 2x. Okay, these lines are horrendous. What is happening here? I don't like this. It's happening. Okay. Apparently it doesn't want to cooperate. But you get the idea, okay? I'm not going to create a chart. So basically what it would look like would be this, right? It's going to look like that, okay? It's going to get compressed horizontally, all right? So that is going to be our new graph. And our theorem here, hold on. Okay, so the graph of y equals f of cx can be obtained. Okay, it can be obtained by stretching or compressing horizontally. Okay, by a ratio of absolute value c to 1. Okay, so are there any questions? Any questions? Oh, I forgot one part. Well, if c is greater than 1, you're going to be compressed. Going to be compressing. Okay, then if c is in between 0 and 1, then you're going to stretch. Okay? So are there any questions? Oh, wait. Not really. This part is okay. So hold on. Just compressing horizontally because not well stretching and compressing. It's on a different ratio. Okay, so horizontally, and then if you write this again, c is greater than 1, compress. Okay, if c is between 0 and 1, stretch. Okay, so now what happens when you have y equals f of negative x? What happens then? What happens then would be this, okay? You're going to reflect over the y-axis now instead of reflecting over the x-axis. So if this is our original graph, then this would be our new graph, all right? We would reflect over the y-axis. That's how we calculate f of negative x. All right. So are there any questions? Any questions? Okay. Yeah. Okay. So our next theorem here will be absolute value, but okay. It seems we have enough time to do one more. Right. One more. Okay. So what we need to do here is actually, if you get theorem 5, you'll probably get theorem 6 because they're kind of interconnected. I mean, absolute value, right? Okay, so basically, I'm not gonna, since we're running out of time here, I'm not gonna, just gonna write much for these theorems, okay? Well, okay, so let me just write them. without doing an example. You should understand this. Okay, if you have any questions, I'll do the example later. Okay, so the graph. So if you're going to do the absolute value, the domain is going to change too, right? So let's say we're going to have this inequality, right? Okay, so that would yield -4 to 4. So therefore, if we did example, okay, hold on, we need this graph here. So this is our example, and if we did absolute value on it, it would look like this, like a mustache, right? Because this changes the domain and this makes it bigger, right? Just multiply the domain by 2. All right, so we're going to have like this kind of mustache shape right here. Okay? So the theorem is the graph of y equals f of absolute value of x is the same it's the same graph when x is greater than or equal to 0, and reflected over the y-axis. Okay, if x is less than 0. Okay, so that is how this theorem is going to work. So let's say if you had actually, let me pull up a good example. What if it was like this? What if you're going to have no, what if you had a graph like this? Okay, one part is negative, all right, and you're going to find what is y equals the absolute value of x. Now, since the absolute value of something cannot be negative, then you can exclude this part, right? This part is irrelevant. Okay, it's just because the absolute value of x cannot be less than 0. Cannot be less than 0. So if you're to do that, then you see here, we're going to do this, right? It's going to look like this. Okay, because we're only reflecting this part, only this part. Okay, so that is how it would look like. So if you had something negative, all right, then that's irrelevant. Okay, so now let's look at our last theorem here. We don't have much time, so basically this is basically the same thing, right? Let's say you had a parabola, right? You had a parabola. Okay, let's not do that. So if you had a parabola, okay, and then you had y equals f absolute value of x, f of x, okay, then well, actually we have a parabola here. Since the absolute value of f of x must be positive, if the absolute value of f of x is positive, then the absolute value of y it must also be positive because y equals f of x, right? So basically what you're gonna do is you're gonna reflect. You're gonna reflect all the y values, okay? All the negative y values. It's gonna look like a W here, right? That is what it's gonna look like. Okay. So we're running out of time. We just ran out of time. So I'm gonna talk more about these absolute values later. Okay, so next class, and I'll see you next time. Thank you for listening. Okay. if you have any questions, put them in the chat right now, or I'm gonna end this class. Okay, if there are no questions, then I will end this class. Thank you. I'll see you next time.